Hi and welcome to yet another episode of the New Space India podcast. Today we have here the CEO and CTO of Elena Geo Systems, Colonel Velan here. And it's a very interesting, company, I would say, because I looked at his background and he being a military person and then now doing technology and providing independent solution as an entrepreneur is a very rare thing in India, as I can see it as well. So I think it's a fascinating company and I look forward to chatting with you. So welcome to the episode, sir.
Thank you. Thanks a lot.
So let's begin with your own military background and what you have experienced in the military and then you leading to becoming an entrepreneur. So give us a little bit of a background into how was your military days and what did you learn from your military days, and what led you to actually saying that look, I want to build actually a solution by myself and do it in the private sector and have a company of my own.
Yeah. See, I am basically a fighter in the military. Whose fighter means basically infantry officer, who's actually when you think of army means you think of people like us, not any hi-fi person. I'm similar type of person. We have been using GPS for quite some time. When GPS was inducted into our services, I happened to be the team leader of the team which did the trials for GPS. That time also we found how GPS was not useful. Actually, some device we were given from one other company ex-US. But people told us to adapt ourselves or try to manage what is possible at that time. So this was way back in 1998. Then what we had is that in 2000 during our Kargil war, GPS as a service was denied to us. Though we had a lot of equipment which is GPS oriented, we could not use it because out of their own understanding and their own perception of Indo-Pakistan conflict, US increase inaccuracy to that level that we can't use it. This single incident has resulted in loss of more than 100 lives to Indian Army. So this set us to think, the higher people or the government also, Indian government started thinking about it, and they said we should get into this navigation domain in a big way. So then from there we had the starting, and then by the time Gagan was being implemented for supporting international civil aviation. And so in 2008-9 and all that, we worked on to devising our own system. I say, after all, as a country, we need to have our own system. Main thing that we found out in GPS is that GPS is suitable for the temperate region. See, which are the countries are using it today? The countries like USA, UK, European Union, and you go along the same temperate region. For the polar region, Russia has got its own GLONASS system. There was nothing for the equatorial region. Equatorial region, when Jonathan McKellar is there, he's a boss of all the ionospheric studies in the world. And the ION Institute is there. He's de facto chairman of ION Institute also. Now, he has done studies for 10 years to model equatorial region. He could not do it. Because they all know that GPS cannot be used in the equatorial region. So along with that, we, along with ISRO, took up a challenge. And then we started creating our own system. Government of India created a small cell called Integrated Space Cell, where they posted me as one of the officers who got experience both in the fighting side also and in the little bit of technology side also I had experience. So they put me there. From there, we then worked with ISRO and then had formulated this idea of having NavIC in place. So NavIC, when the satellites started going up, we found that no one is coming forward in the ground segment to develop all this. So that propelled me to get into this domain, because after having designed a system, just putting up a satellites, if it's not used, won't be good. So then I started putting up my own company. Before that, when we develop a new system, we need to do a lot of R&D. There's no two ways about it. When GPS was put up, US did R&D for a decade. Same if you're putting up a system for India or NavIC for the equatorial region, we need to do some studies. So we had, to do this study, we had approached Indian universities, they had taken up. I also was sent from our ministry to do a study on this topic, actually PhD from IIT Kharagpur. I was initially sponsored. Having gone there, I found that it's better to move out of services. Then I resigned and then went there. Put up company in IIT Kharagpur to concentrate on the research and development aspects, collaborate with people around the world. And that's how Elena came into being. And we initially were only research oriented. We thought that we'll make some algorithms, make some ideas, give it to Indian companies to proliferate it. but then it did not take off. So we started getting into one domain ourselves. First, we went into the software domain in terms of logics and algorithms required for Indian terrain or the equatorial region. We went for that. And later on, we found that no one was working in the hardware side also. Satellites were started going up in 2017. And we found that there's no one working in the hardware domain also. So that's how we went on to hardware domain. Willy-nilly today, it's not by design, by default. We have been pushed into both hardware and software, and we were working with the same sole aim of giving NavIC related services for the country or for the region actually. For example, my company is not something which is IT company is migrated to this, or a communication company migrated to this, not even an electronic company to this. Company was created only for giving NavIC services. And that's why we are completely focused on this niche segment. That's why today we have that good presence in this domain and have this advantage of being first mover into this domain with all required equipment. So that's why we have end-to-end presence today. So that's how my journey from military into establishing this company, how we have come to this level, what we are working today.
Right. So very, very interesting as to how you began and then how you have evolved in that process. Right. So from an audience standpoint, I think many people don't really know what is NavIC, because NavIC is a very catchy word, but many people don't know what is NavIC. So I think what would be interesting to the audience as well as I guess generally from an understanding point is for you to probably tell us what does NavIC mean both technically and for an end user perspective for especially a country like India, and what potential does it hold, and where are the blockages that are present that we need to unlock?
Yeah, NavIC, the word NavIC can be interpreted in two ways. Complete word, NavIC means a boatman, someone who takes a boat along, someone who guides a boat. So NavIC is that, and it's also an acronym which means navigation with Indian constellation of satellites, navigation of satellites. So that's NavIC. See, NavIC, the name also originated from the word navigation. India gave the word navigation to the world. Navigatit is a science written in our scriptures. From that word navigation came. That's how the word navigation came into the English also. From navigatit, it went to navigation. And so we being leaders in this domain, we put up a system for navigation using our own satellites. Like GPS has got its own constellation of 24 satellites, which gives you service around the world. We started putting up 7 satellites initially to cover the Indian region. Slowly we are increasing the orbit. And then now we have a complete constellation of around 12 satellites giving you NavIC systems. We put up 2 systems. One is IRNSS, which is like GPS, replacement for GPS. IRNSS, replacement for GPS. IRNSS means Indian Regional Navigation Satellite System. The separate system that will give you all activities of a normal navigation system. The focus was initially India. Then we had put up Gagan system, which is an augmentation over GPS to be used by civil aviation people for the aircraft to fly. So in civil aviation side, we had WAS, which is over America. Then we have IGNOS over Europe, which is giving augmentation to GPS signals. Why augmentation is required is the GPS signal that we are using is a coarse/acquisition signal. Per se, it is not correct that they have told. The high precision signal are being used by military people, by the US government, which is not given to everyone else. So to improve this accuracy of coarse/acquisition signal, people started putting different methods of increasing it. One is to have additional satellites that will give you more coverage, and it will increase accuracy to a level which can be used by the civil aviation. It's actually 2 meters along the horizontal plane, 7 meters in the in the vertical plane. That's a cylinder you have to fix the aircraft. So that's possible with the augmented signal. That's how we got WAS, which is in America, IGNOS, which is in Europe. This side in Japan, they put up on EMSAS. So in between IGNOS and EMSA, there was a gap. Then they requested India to put up a system which will enable world over flying of aircrafts. So that's why we put up Gagan. Gagan we put up, and Gagan we found that is much more better functional. I mean, most of the time with using Gagan, you'll get 1 meter accuracy. Though design is only 10 meter accuracy. And it's a 2 meter by 7 meter is a cylinder what people want it also. But then Gagan will give you 1 meter accuracy. With that expertise in hand, ISRO put up our own system of satellite called IRNSS. Similar technology adapted for larger thing. So today we have 3 Gagan satellites, 9 IRNSS satellites, total 12 satellites, which covers from Africa to Australia along the equatorial region. See, we are giving services which is good in the equatorial region. In the temperate region, obviously GPS which is designed for it will be better. But if we have a system which takes GPS also and IRNSS also, we'll have covered both the things. And if I have a system which takes GLONASS also, I have to cover the entire world. So that's the approach which we as a company have also got into it. That's the approach which is more logical approach. So ISRO also, our government of India also has adapted it. That's why they integrated Gagan with IRNSS at the engineering level. Through Gagan you're getting GPS and we have IRNSS. Both put together as NavIC, any constellation of satellites. So navigation with Indian constellation of satellites. So this is NavIC. And NavIC, when you say NavIC, we are talking about IRNSS, we are talking about Gagan. When Gagan we're talking about means we are extending or taking help of GPS also. So this gives you best solution almost around the world. That's NavIC for you.
Right. Again, super interesting. So you talked about your company's, DNA being the use of NavIC in our country, in our region at the end. So what sort of services are you looking at? Is it that you see more adoption coming from the military side because you have an insight being a military man? Or do you see, adoption across the board in other areas as well? So what is the areas of adoption are you seeing, and how big is the appetite? Because obviously GPS receivers on the ground are very cheap and very low cost, and it's something that people would want to use because maybe it's not as high accuracy that as NavIC would provide, but then it's super low cost. So it's always a gamble with the cost and the accuracy at the same time, right? So I'm no expert in this, but I would love to hear your thoughts on these.
Yeah. See, first about NavIC, it's a new system that's coming in, new technologies. So everywhere we have to develop different types of equipment. We cannot use GPS equipment, or we can't even extend it or modify it to use NavIC. That's a basic fact which people should understand, because NavIC uses a different frequency, different signal pattern, a different message formats, all that is completely different. So one of the main reason is that GPS is flying at 20,500 kilometer average height, GPS satellites. Whereas our satellites, the NavIC satellites, are at 36,000 kilometer height, double this thing. So the antenna has to be more precise. It has to take a signal which is almost 1/4 of the signal which is being received from GPS. Then the size also bigger because for message format is different. We have to have 5 megahertz width to have a proper reception. So these are things that makes NavIC equipment separate from GPS. So when we are making some new equipment, it will be obviously costly. Like a GPS instrument in Indian rupee terms only, when for Commonwealth Games we use something of 1 lakh rupees capability. Same thing today available for 10,000 rupees. So that even when proliferation takes place, NavIC also cost will reduce. Even now, cost is all comparable. Because people like us who provide solution, we provide a composite solution. We don't only give you NavIC only. We give NavIC plus GPS plus GLONASS. So one instrument which can be used everywhere. And when a new such technology comes into the country, we need to have, or the user needs to have the complete series of equipment which will give him the final output. He is not bothered about a chip being created or an antenna being created or a small device being created. One has to have every complete solution. So that we as a company have worked in that direction to provide a solution basically. So we have an antenna, not just one antenna, a range of antennas. Some will be used for military users, some will be used by transport people, some will be used by individuals, a range of antennas. Then NavIC has got different signal bands. So NavIC signal bands are there. So we have dual band antenna, tri-band antenna, single band antenna, like the combination is there. Similarly, matching modules we have. Modules means it's not just one chip. In the navigation domain, 2-3 chips have to work together to give the final output where you are, that latitude, longitude should be taken out after 2-3 chips do the processing. We put everything into a module. So this module, what is what we made, and this module also got variants. Some tri-band module, quad-band module, dual band module, some for consumer market, some for defense. Like that we have same devices, different type of devices as and when, see right now we have only certain prototypes, but when a demand comes from a particular user, we make the device and give to him. What is beautiful in our side is that we have got, if it's for a vehicle tracking application, for example, if we just don't give the hardware only, we have the tracking server also with us. We have a map server framework, which can take map from any source like Google Map or any other map source it can take and provide the user with a complete solution. So we are in the hardware domain and software domain. With this, we are able to give you a solution which is most cost effective in the equatorial region and more so in Indian context. So as a cost wise, we are almost equal. We will be slightly costlier, but yes, because two devices, three types of devices are being used, it will be slightly costlier. Yes, that is it. But overall, the benefit that will accrue out of using our equipment, in context of GPS also, with respect to GPS, is much more. Because we are trying to use GPS for whatever reason people in UK or European Union are using. Same thing, when you use same equipment here, it will not function. So our equipment is a solution for it. To say in other words, for example, if you use our equipment, you will save in losses up to 50%. Your efficiency will increase up to 30%. Result in doubling your production for the same set of resources that you're having. I have done this study in mining domain. I've done this study in steel industry. And I've done this study in another mineral processing industry also. We have proven to them that using this technology properly, the output will be doubled. Let's say if a mining company is doing 1 crore rupees turnover per month, it will go into 2 crore rupees for the same set of men and resources, only using this technology, not my technology, using NavIC technology, I'm saying per se. We happen to give you the right equipment, but NavIC is a source which we take and give to you. So that's a beauty of it. So when you say the interplay of NavIC and GPS, yes, there will be some cost increase, but that will also result in productivity increase also. So it will offset everything for the user. So that's what we are.
So I think the one thing that we would like to hear is, the application side. Let's probably explore the military side first and then the civilian side later on. So obviously, I think from a sovereignty standpoint, NavIC plays a very important role in the. So I think the one thing that we would like to hear is, the application side. Let's probably explore the military side first and then the civilian side later on. So obviously, I think from a sovereignty standpoint, NavIC plays a very important role in the military. Obviously, integrating that into all sorts of systems on the ground, in the air, and even in space for that matter, with the LEO constellations that India operates to a large extent. So, how deep is this integration at the moment, and what is the scope for achieving sovereignty in our systems using NavIC?
Happens in GPS. It's got 2 signals. Same it is with GLONASS. The Russian thing also got 2 signals. One is open to the public, one is for services and all that. Indian government or NavIC also has got 2 signals. But Indian government has taken a conscious decision that both will be of high precision and both will be free for the entire world community. What Indian government is seeing is that through space, they want to develop human cooperation. So this is being seen today as an tool of foreign collaboration or cooperation amongst countries that are developing. So this is given to other countries also. And while giving it to other countries, for example, when we use some tracking devices made of GPS, generally the server is being white labeled from a company in US or a European company. So data ultimately resides with them. Indian government has made it mandatory that data will not reside with anywhere else except in that country which is asking for it. So today we have a solution where we go give it to the country, the entire thing becomes theirs. No questions asked. Indian government has assured free service, high quality service given to them, and we can give entire equipment, they can manage from then on and manage it. That's all. We only give the technology to them. So the sovereignty of the country is, not only India, of other countries which use NavIC also is protected. So that's how designed by India when this project came up, and it's working well now. So then, who are the users of NavIC? There are 4 types of users. One is defense, we all know. The moment we talk about GPS and all that, first thing that comes in mind is some rocket getting fired somewhere and some missile going or a drone going. Okay, that's what comes in mind. But that is just 5% of the utilization of this technology. Huge utilization, which is rightly so in US also. The adoption is into agriculture. Adoption is into logistics. It is into transportations. It is into shipping, civil aviation. So the majority user is public. This technology, majority user is public. Only 5% is defense. Around 15% will be government users. Will be using some high precision signals. For example, the land survey people will be doing managing records, land survey records. They need some amount of application. Someone who doing that mining or just studying mineralogy or doing this like we have geological survey, which will use this type of equipment. 15% there. Rest all is public. Around 20% only this type of users will be there. Rest of the market is public. And in that we have corporates, we have individuals, we have government agencies giving services, someone else is giving services, all this put up. When I say public means I'm talking about all this segment, which is cost conscious, but utilization is very high here. Like now EV vehicle will use navigational signals to track themselves for various reasons they have. And user of this EV vehicle is public. It's not the government. Government is just mandated. They might use some amount of vehicles. Defense might use few number of EV vehicles also. But majority users are only public. So this technology per se, majority users are public. And public are the people who will drive the way it is supposed to be used. So in our context also, NavIC is not just, it's not stabilized in whatever it is. Like GPS put up 2 signals, that it is what it is. It's not that way in NavIC. NavIC is an evolving system. So now we are trying to put more services. ISRO has already called us, and then speaking to people like us who are developers of NavIC solutions, they have already shared with us that they are going to put one more signal in the L1 band, which will be then allowing us to use more better use of NavIC will be there. Maybe we'll put up more services. That's how we plan to go. So NavIC per se, majority beneficiaries will be public, and it will be used for public to make public life easy actually. Basically to enable human activity, better human activity. That's what we'll have.
I'm pretty sure that in your own journey, there is a lot of mismatch between end users who probably don't know what they can achieve with GPS signals. Like you talked about the steel, industry to a large extent. And I'm pretty sure that you might have to go build capacity in them and educate them about the usage of these signals and how it could be beneficial to these communities. Can you share a couple of stories around, these aspects and how you have discovered that you could work with a certain end user community or a group and build capacity in them, and then them adopting the whole solution might have had an impact on their work at the end?
Yeah, I can do that. See, as I said, before even NavIC satellites started going up, we put up a company to do research in this domain. Then, so our company was actually created in the technology business incubator of IIT Kharagpur. And we were doing research in the mining domain. There we met Jindal Steel, the JSPL plant, which is near Ranchi. This off Ranchi, Patratu is the place where this plant is there. Now their president called me up and told that, Velan, can you suggest a solution? One of the meetings, I gave a presentation or a talk on a miners day, and then mining engineers day, I gave a talk in Tata mines. Then from that they called me and asked me. We studied their thing, and we came up with 2-3 solutions actually. One is to do with the vehicle utilization. See, they were using 50 vehicles. They were using 35 vehicles and had plans for 50 vehicles to be used to move around people, normal factory work. Ranchi is the nearest town, but it is 2 hours away, and another town was beside. So they were having around plan for using 50 vehicles. They wanted us to give a solution for 50 vehicles, to ensure better efficiency or utilization of these vehicles. When we gave our solution and they started using it, within about 6 months, the total utilization of vehicle came down to 7. That means so many repetitive tasks got combined, and so many, we suggested many methods. So from 50 to 7 we came. They had 3 dedicated vehicles, so we can take it as 10. So 80% efficiency, 80% reduction they achieved, and think of the efficiency pattern based on that. That's what they did it. Then they had this, some set of vehicles have to go along looking at electric line. They were supposed to give electricity to nearby place, nearby town. So they put up a separate electric line, about 125 kilometer electric line, and a separate pylon and all is coming up. There was someone to go check this items are dumped on ground, just to see the protection of it. When we started, they were giving X money, and people are going up. X money also arrived at saying, okay, this is the distance, this is what calculation, all that they have done it. But when they started using this technology for monitoring this progress of the inspection part, then they found that they can reduce the money by 50%, and they reduced it by 50%. Here, when they reduce 50%, it's not the contractor is unhappy about it. Contractor is also happy that he is making money, and the company is also, the corporation is also happy that it's making money. So actual money utilization was only 50% of what they were spending. Actual terms is 1.5 lakhs they were giving per month per person to doing this inspection of towers and all that. After some time, they reduced it to 75,000 rupees only. Directly 50% reduction in cost. See, all this is saving. And we done this project as well as trial projects. Later on, we said that we were using this project based on solutions out of mobile phones. Then we said, when NavIC satellite comes up, please transfer it to hardware. And that's where we told them only to implement. See, it's once people have understood, they have their own IT people who can implement solution, and that's what is it. So as a solution, you see how much of efficiency is brought in. That is one aspect. Next is Balasur Alloys Limited. It's a factory which works on to special, mine, it's a special ore actually. They make these pellets and send it to world over. They are only people sending. Huge factory with around 3,000 workers. There again, we sat with them and told them where are the places your technology, you are losing out money. And then we gave out a listing. There again, we found that their efficiency pattern in which they had initially arrived was 0.7. That is 70% efficiency they were working on. But when we calculated, we said your efficiency is only 0.3. With 0.3 efficiency, they were having a turnover of 50 crore rupees. We said we'll increase it to 0.5 with this technology, which will double the output that side. And then they were totally without doing any additional investment, by just giving small investment into this technology, they found that they can double this their production capability, save on losses, which is good for either side. Good for the country also, good for them also, the corporate. And they saved everything. So they are ready to take our technology. These are certain examples where I did a study closely with the mining people. As we have done some study in Novamudi area also, in the mines where the Tata mines are, the Tata Steel mines are there. There also we did some study and we presented some reports. So this technology, these are certain examples where we have actually studied and told them. Recently we did a study for one of the port near Chennai, a privately owned port, Krishnapatnam port, where we told also how the operations can be further, efficiency can be brought in, cost which they are also trying to use this technology. They use GPS related technology with high cost. We said we can use NavIC, how it will reduce. We have given a presentation to them. That's all. And it's a big eye opener for them also. The cost, we'll say costing basically, we are talking about NavIC being high, more than that thing. But GPS, they are already giving it an exorbitant cost they're getting from Europe, some GPS equipment. And when we compare that cost with our Indian NavIC product, it's not even half of it, less than half of the cost of that product. So per se, for Indian companies, at least, ours will be a very cost-effective solution.
Right. Again, very, very fascinating from all the aspects. So from all the applications that you are talking about, I guess also a lot of this is related to India. But as a company, are you looking at, replicating these applications? Because all the applications that you talked about are country neutral. All of the other countries in and around the equatorial belt and this region in which NavIC serves, they obviously can use a lot of your equipment and solutions. And this is a theme that I see with a lot of the new companies who have great potential in India, right? Where you can build a solution that you can pilot in India and see if there are end users for it in India. But once you have this fit with an end user, you can start suddenly selling it to Southeast Asian countries or, African countries or other such places. Have you explored any of these newer geographies, or are you still looking at breaking into other end user segments or looking at other aspects of this? Because at the end, there's huge potential for you that you can go, deep into one vertical or broad into other horizontals. So what is your progress have been in the last, few years as such?
Yeah, as you say, this technology is for the equatorial region. It's not India country specific. We have done some studies in India. See, beauty of India is that all terrain aspects that are there elsewhere in the world are available in India. Apart from that, we have additional terrains which are available in India but not available elsewhere. Climatic condition, which is available elsewhere, is available in India also. So, and cultural orientation also. See, India, we are ourselves multicultural people. If I go to, say, Indonesia, whatever cultural part of Indonesia is available in India for me to do experimentation. So, per se, this technology can be used by anyone. So, we also have been working similarly. We are actually doing trials from Africa, from Mauritania, which is West Africa, to we are doing in Kalimantan, which is in Indonesia. So we are working with all these countries. We include Middle East also in between. So first, our technologies can be used effectively. We have done a study just before COVID. Because of COVID, then things got stopped, investment got stopped and all that. One good hope is there. They are big into this palm oil production. So we did a study for them, and they were again impressed with this ability of, if you use the technology properly. See, GPS will give you advantages. That's there. But those advantages, to translate it, we need a GPS of our region. That's the right way of understanding it. That is NavIC. So it's a thing which is NavIC. If you use NavIC properly, we'll get these advantages. Because your accuracy increases. You can easily plot people exactly what time coming, what time going. And they found that their output they were supposed to invest X amount. They're getting 3X amount within 1 year. First year itself. That's been proven to them. So we have been working in Indonesia. We have been working in Thailand. Then with people in Thailand. Some trials are going on and some discussions are going on. Everything got disrupted because of COVID. Then in Middle East, basically Oman and I think Dubai and those basically UAE countries, we are discussing with them. In Africa, we are talking in talks with Nigerian people, with Mauritania, then Senegal, then Libya is what we are, Ghana, Ghana, there is it's Libya which we are in touch with. They are the people whom we are working with. So these people will observe, if they observe the technology, basically concentrating on the equatorial region, or this is a region in which the developing countries are there. That's all we are working. Also southern Europe. One girl from Italy came and did this thing with us and just recently gone back. She did 1 month, rather 2 months of what they call internship with us. She's from Italian university. So she'd come and did 2 months of internship with the company, taken this technology to that country. She's from Milan. So Italy also can make use of our thing. NavIC per se will be useful in southern Europe, better than the European system also. But since we're giving composite system, it's overall more effective that way. So these are the countries which we're working on.
Right, fascinating, and I'm sure that we can go on for a long time beyond this. So maybe we'll set up another time to record a deeper episode, and I would love to see some of your own equipment and see how this is working out for the industry. But maybe one last final question before I let you go. Where do you see yourself in the next, let's say, 5 to 7 years? Because you are piloting a lot of the interesting solutions and you're helping industry adopt in the process. And obviously you are dependent on maybe ISRO also to launch new systems that are more effective or so on, right? Because at the end of the day, you're dependent on assets that are up in the sky as well to provide all of these solutions. So what kind of growth are you looking at? And is it that you will have 80% of your solutions being used also outside of the Indian region, Indian subcontinent, and users abroad, or are you looking at India as a market, or looking at drones or other aspects that are coming out? So again, that would be very interesting to you to learn about.
See, this total market potential has been evaluated to be $200 billion. The GPS market is only $50 billion. Comparatively, some study was done in the equatorial region. So ours is $200 billion. We are the first movers, first people in this domain with full system already available. For example, we have the first tri-band module, that is, which uses L1, L5 and S-band, a very small module concept, around 40 mm by 30 mm by 5 mm is the concept of this. This is a form factor of it, which can be used, very stable, can be used for high precision applications. Same, we have L1, L2, L1, L5 module, which is also gives you high accuracy and all that, but more towards the public domain for the consumer market. We have done that. We have got the first drone navigation unit which is working out of NavIC. Then we have got the marine units again first, because we are the first set of people who are giving it, which are being inducted into certain boats, and then tests and trials have been done by Goa shipyard. The shipyard has taken our equipment, fitted it, and then replaced the existing equipment of European origin in that. We are also working with L&T, where they are replacing some equipment which is there, or upgrading our lighthouses. Our equipment will be used to upgrade lighthouses to use NavIC. That again they are using our equipment of European origin, or some other country which is only GPS oriented equipment is being replaced with equipment which is using NavIC. So this is a complete thing. Out of this, majority user today, next about 5 years period, majority user will be Indians, because this technology has been understood by the country, and there are people who are ready to absorb this technology. Slowly other countries will come in. What I see is that ASEAN countries will adapt it faster, because they already have GPS. Moment we tell the difference, it will take on. Our NavIC is into Australia also. Australians are actually, they've used GPS and they're still not happy with that. That's a feedback I got from a couple of Australian societies also. There's a Indo-Australian trade, this thing is IOBF is there, IABF is there, Business Forum is there. They had visited Bangalore, and when they come and contacted me, we discussed, we went to the governor and see how Karnataka and Australia can work together. That way also we had worked. And there we find that GPS technology being used has not given what is expected output, was not there. They'll absorb faster. Like these people, the Nigerian people in African continent, which is Nigeria, will absorb. Middle East people will also absorb faster, because they are already using GPS. When we say, okay, you are using A item, this is better than that. In any case, this item has got a shelf life, and a utilization period. When the next cycle comes, we'll absorb our thing. So what I see for my company is that out of this $200 billion, I will have a percentage of this. Being the first mover into it, we'll have a percentage of this, and we have a plan. By around, in Indian rupee terms, we can say a 2,000 crore company will become in about 4 to 5 years time. That's a focus. Revenue will be there. So that's a growth, because this technology will get absorbed faster now.
So Colonel Velan, thank you so much for spending time with us today, and best of luck to you and your team. I think you're doing some really fascinating work, and I look forward to keeping in touch with you, so that down the line, a couple of years from now, would love to see how we have grown and what is the adoption like, and then catch up on another front of how the business has grown, because I'm pretty sure that this is a very strong area to work in, and there's lots of scope to grow. It's another fascinating Indian company that has global potential. Good luck to you and your entire team.
Thank you. Thanks a lot.